Welcome back. We've got video number 6 in our first unit. All right, today our goal of the day is to highlight the important information that we will have learned over the past 5 days in our algebra unit. In other words, today we're going to fill out a study guide. Many times in math, we do a lot of practice problems, and it's really hard to distinguish between what's a really important piece of information and what's just a regular practice problem. So what we're going to do today is we're going to take all of the important information that we've learned and we're going to try to put it in one location. So that way it's easy for you to prepare for your upcoming quiz. All right, so let's take a look. The first thing we reviewed this year was your different number systems. So our first number system are your integers. Now, integers are positive and negative whole numbers. So for instance, we could have any negative number but -3, -2, -1. Then we can go to 0, 1, 2, 3, and we can go all the way up to infinity. Now, a rational number. A rational number is any number that terminates or repeats. So it can do either one. It has to either terminate or repeat. So an irrational number is the opposite. It is a number that never terminates and never repeats. So it has to do both. Never terminate and never repeat. All right, let's try 2 practice problems. Okay, so here we go. Example number 1. We are given the variables L, M, N, and P. It says which expression results in a rational number. So the nice part about a question like this is we actually have our handy dandy calculator that can help us out. So we want it to be a rational number, so that means we want it to repeat or we want it to terminate. Remember, terminate is just a fancy way of saying it ends. So let's take a look. L plus M. So L is radical 2, so the square root of 2, plus M. M is 3 radical 3, so 3 square root of 3. Oh, and look what I did. I goofed. So I'm going to go ahead and clear that out. Okay, and I'm going to start again. So radical 2. Now I have to use my over arrow to get out from underneath that radical symbol. Now I'm going to go plus 3 radical 3, and I can use over again, and then enter. So this number is irrational. It goes on forever, so I'm going to cross that one off. So let's go ahead and try B. So 3 radical 3 over plus, and then N is radical 16. Again, that's irrational. So now let's try N plus P. So N is radical 16. I use my over arrow, and then radical 9. Oops, and I forgot my plus, so I'm going to go over, second, insert, a plus symbol, enter. And I get 7. So 7, it terminates, it ends. So that would be my answer there. That is my rational number. All right, so let's take a look then at example number 2. Sam said that the product of these 2 numbers is a rational number. Do you agree or disagree with Sam? Explain. Well, first we have to remember product. What operation is that? Okay, well that is multiplication. So we're going to multiply these 2 together. So let's go ahead and actually multiply them to see what we get. Okay, so 2 square root of 3 over times 5.5. So we get 19.052558, and it's going to keep on going. So as I can see, we have a number that never ends, and it looks like a couple of the numbers repeat in our calculator. A couple of them are repeating, but we don't know for sure that it is going on forever repeating. So this is indeed going to be an irrational number. So I'm going to say I disagree with Sam. Because. Now, because we have that word explain, we have to write the word because. The number never ends and never repeats. And we've got it. All right, so that's our number systems. So now let's take a look at our algebraic properties. Okay, so our algebraic properties, we had 4 of them that we learned. The first one is the commutative property, and the commutative property is where we are going to switch the order. So if I take a look here, I have 5 plus parentheses x plus 2. So when I switch the order, instead of the 5 going first, I'm going to put the parentheses first. So x plus 2 and plus 5. Associative property is where we are going to change the grouping. So if I look here, I've grouped together the A and the B. So when I rewrite this, I don't want the A and the B to be grouped anymore. So I'm going to put the A separate, plus, and now I'm going to group together the B and the C. Okay, the addition property of equality is where you have to add in order to solve. So for instance, if we wrote if x minus 2 equals 10, then, well, what do we have to do to solve this? We have to add 2 to both sides. So plus 2, we would have x equals 12. And then the subtraction property of equality is where you have to subtract in order to solve. So we would have to make sure that we had addition in our equation, because now in order to solve, we have to subtract 2 from both sides. And we get x is equal to 8. And we've got it. All right, the next big key idea that we worked with is unit conversions. So let's go ahead and take a look here. Our example, there are 1,760 yards in a mile. It took Charlie 900 seconds to run 3,520 yards. What is Charlie's pace in minutes per mile? Okay, so we're going to have to change some things here. So if I take a look here, Charlie is starting with seconds, and we want to end in minutes. So we're going to have to convert that. We also have yards, and we want to change that into miles. Okay, so we're going to have to do 2 different conversions before we can put it as a rate. So I'm going to go ahead and change seconds into minutes first. So we start by writing down what we're given. So we're given 900 seconds over 1. Now I'm going to multiply it by its conversion fraction, or its equivalent fraction. So I know that there are 60 seconds in 1 minute. So I want to end with 1 minute. So I go 1 minute over 60 seconds. And I'm putting seconds in the denominator because now my seconds in the top cancels with the seconds in the bottom, and I'm left with just the minutes there. So this is going to be equal to, let's go ahead and divide it out. So 900 divided by 60, and we're going to get 15 minutes. So that is going to be my time. Okay, up next, now we want to convert yards into miles. So that's going to be our distance conversion. So I'm going to start by writing down what we're given. So we're given 3,520 yards over 1. And I'm going to multiply that by my conversion factor. So I know, and it actually says it right here, there are 1,760 yards in a mile. So I'm going to put 1 mile on top over 1,760 yards. And the reason I put yards in the bottom is because now yards on the bottom cancels with yards on the top. And I'm left with just my miles, so I can use my calculator here. So I'm going to go ahead and 3,520 divided by 1,760, and we're going to get 2 miles. So now we want to end with the pace in minutes per mile. So now I want to do minutes per mile. So let's go ahead. We had 15 minutes per 2 miles. So if I were to divide that, 15 divided by 2, we're going to get 7.5 minutes per mile. All right, and we've got it. All right, so we're going to carry on now to our monomial properties. So our first monomial property was to make sure that we know how to combine our like terms, adding and subtracting. When you add and subtract monomials, we're going to combine our like terms. So here we have A and B. So we're going to go ahead and find A and B. I'm actually going to cross off the addition one. I want to go right over here to the subtraction one. So here we are subtracting quantities. So we want to make sure we put those in parentheses. So we are going to put these in parentheses, and then it's going to be B minus A. So I'm going to go ahead here and write 2x squared plus 7x minus 2 minus x squared minus 5x plus 3. Now the reason that we did this is because we now need to distribute this negative to everything. We're subtracting the whole thing. So this is going to become 2x squared plus 7x minus 2. So the first is going to stay the same. Minus x squared. So a negative becomes a positive 5x. And a negative times a positive gives us a negative 3. And now I can combine like terms. So 2x squared minus x squared is just x squared. Then we have 7x plus 5x gives us 12x. And negative 2 and negative 3 gives us negative 5. And we have our final answer. Okay, next up, we're going to multiply our monomials. So when you multiply monomials, you're going to multiply the coefficients and add the powers. So our first example, what is the product? So we're going to multiply. So 24 times 1/2 is 12. X to the 5th times x squared, we're going to add the power, so that gives us x to the 7 and y to the 5. Okay, next up here, we are still multiplying because with distribution is just multiplication. So 3xy times x squared gives us 3, so this x is to the first power, so this is going to be x to the 3rd y, plus, then we multiply here. We get 3x squared y squared because we have 1 plus 1 is 2. 1 plus 1 is 2. And then we're going to add, and then 3 times 1 is 3. X is going to stay the same. And then y times y squared is y to the 3rd. Okay, raising to a power. So when you raise polynomials to a power, you're going to multiply the parentheses as many times as the power. So here we're going to write out the parentheses as many times as the power. So we're going to write it out 3 times. Okay, and then we just have to multiply. So negative 2 times negative 2 is positive 4 times negative 2 is negative 8. And then x, we have a power of 1, 1, 1, so that gives me x to the 3rd. And then we have y to the power of 5, 5, 5, 5 plus 5 plus 5 is 15. And then z, 2 plus 2 plus 2 is 6. And we've got it. All right, let's flip it on over. Let's take a look. So next up we have dividing. So when we divide monomials, we are going to reduce the fraction and subtract the exponents. So if I take a look here, we have negative 12 over negative 16. So in my calculator, I'm going to show you the trick. So negative 12 divided by negative 16, we hit math, okay, and then 1 is frac, and then we hit enter, and we're going to get a positive 3/4. Then we're going to subtract the exponent. So here we have x squared, x to the 4th. So 4 minus 2 is 2, but the bigger x is in the bottom, so this is going to stay in the denominator. And then we have y to the 3, y to the 1, so 3 minus 1 is 2, and the bigger y is in the top, so y squared. And we've got it. Okay, if we take a look at the next one, this one is a little bit different because we have a trinomial on the top and a monomial on the bottom, which means we actually have 3 individual fractions here. Okay, plus 6x to the 5th over 3x squared minus 24x squared all over 3x squared. So we're going to have to divide 3 times here. So when we divide 9 divided by 3, 3x, we subtract, we get 5. Plus 6 divided by 3, we're going to get 2, and then we subtract and we get x to the 3rd. Minus, we're going to divide and we get 8. X squared, they are going to just cancel and we get just 8. Okay, so continuing on now, we have writing parts of an expression. So let's take a look here. Write a trinomial expression of the 6th degree with a leading coefficient of 3, a constant of negative 8, and a term with a coefficient of negative 2 and a power of 3. So here it says write a trinomial, so that means there's going to be 3 terms. The expression is of the 6th degree, so the highest power is going to be a 6. The leading coefficient is 3. Leading coefficient is in front of the highest power. A constant of negative 8. Constant always goes at the end. And a term with a coefficient of negative 2. Coefficient always goes in front of the variable, and a power of 3. We've got it. Okay, I'm going to end here, and we will finish up in class tomorrow.